Now we're going to talk about evaluating expressions. Should have an S up there, evaluating expressions. When you evaluate an expression, most of the time you're actually finding the answer. And this is something that's actually really powerful and used in the business world a lot. All right? So if you're going to evaluate an expression, you can do this if you know the value for each variable in an expression. Okay? You can substitute and simplify the expression. So if you know the value for each variable in the expression, you can substitute and simplify. What does that mean? Well, I want to bring it into a real-world example here. I've written an expression on the board, 0.3t plus 2,000. And this is an expression that many stadiums use to calculate how many hot dogs they should prepare for a given game. So if you're in Houston and you're going to watch the Houston Astros, and it's against a really good team, maybe it's going to be a sellout or close to a sellout. So 0.3t plus 2,000 tells them how many hot dogs to make. What do you think the T stands for? The T stands for the number of tickets that they sold. So if they sold 40,000 tickets for that baseball game, 0.3 times 40,000 plus 2,000. Now, notice I put a star on the order of operations. After you substitute in, you still have to follow the order of operations. So we've got some multiplying to do, then some adding. 0.3 times 40,000. I'm going to give that to you. It is 12,000 plus 2,000. They have 14,000 hot dogs that they need to prepare for that game. All right. If not as many people show up, I'm going to erase this here. What if it's a terrible team or a team nobody likes? It's just not a very big drawing team. And what if only, oops, that's 0.3. What if only 15,000 people show up? Well, now that it has changed, you put in 15,000 for that. 0.3 times 15,000, I believe is 4,500, plus 2,000. They're only going to prepare 6,500 hot dogs ahead of time for this game. So you see, the expression gives them an idea of how many hot dogs to prepare. You can use that all over the place in business. Expressions are very powerful. In math, we don't give you the nice story to go along with it, but we still expect you to be able to substitute and solve. So you're going to see something like 3x plus 5 if x equals 9. You put in the 9 for x. 3 times 9 plus the 5. Follow the order of operations. 27 plus 5. The answer there is 32. For the second one, my expression is x squared plus 5x plus 3. So I'm going to put in x is negative 3, so I'm going to put negative 3 in. I've got x in two different spots though. So I'm going to put in negative 3 here for the x squared, and I'm going to put it in plus 5 times negative 3 plus 3. I didn't say this, but I feel like it makes it a little safer. Every time I substitute, I always put the number I'm substituting in parentheses. This makes sure, for example here, that I know that I have to square negative 3. If I didn't use the parentheses, I might miss that, and I would end up coming up with negative 9 there, where negative 3 times negative 3 in reality is positive 9. So I did my exponents first. Now my multiplying and dividing, that happened to come in a nice order. 5 times negative 3 is negative 15. So I'm going to change that minus to a minus 15 plus 3. Running a little short on space here. 9 and negative 15 and 3, when you combine them, that is negative 3. So the answer for this one is negative 3. Sorry, I got that a little crowded. The last one looks like a real monster. It's got ax plus 3by minus 19. There are 4 different variables in this. Notice I had to give you 4 different values for each variable. So I'm going to go ahead and substitute those in. For the a, I've got a 3. For the x, I've got a negative 5 plus 3. The b is negative 7. The y is negative 4. And then I have to subtract 19. Didn't do very well here on space organization. But now I have them all substituted in. Let's go on ahead and solve them. That's our order of operations. Nothing to do inside the parentheses, no exponents. I got to do all my multiplying first. 3 times negative 5, that's negative 15. 3 times negative 7 times negative 4. 3 times negative 7 is negative 21. Negative 21 times negative 4, that's going to be positive. And 4 times 21 is 84 minus 19. Now I can combine the adding and subtracting. Negative 15 and 84, that's 74, that's 69. 69 and negative 19 is 49, 50. The answer there is 50. Anyway, just keep in mind when you're evaluating expressions, you've got to substitute in, you've got to solve, you've got to follow the order of operations. Good luck.